Hello guys, today we are going to see a problem that is find searching an element in a sorted and reiterated array. Searching an element in a sorted and rotated array. Now the question arises, what is a rotated array? As all you know, a sorted array, example 1 2 3 4 5, and then now the rotated array is an array in which we have performed some shifts like 4 5 1 2 3 is our sorted and rotated array. In this array is sorted, but we have performed 2 right shifts on it, and in this way it becomes our sorted and rotated array, that is 4 5 1 2 3. Sorted array simply 1 2 3 4 5, and now rotated array 4 5 1 2 3. It is an example of an rotated array. Now we have to find an element in this array. Now how can we find? We can directly find it by comparing each element to the key. So let's start doing in the same way. Hashtag include bits std c++.h. Firstly I will write here my approach so that it will be more easy. It is called a brute force approach or native approach, in which we are comparing each element to the key. Now here doing the basic things. Here we are accepting the size of an array from a user. Now we are taking the key which we want to be searched. Now we are printing our result, that is element founded at if it returns 0, then it means we have it means that the element is not present in our array, and if it is present it will return an natural number, otherwise it is going to return a 0, that is a whole number. Okay. Now we are providing it, passing a function, that is creating a function search L, in which we are going to pass our array A and the number of elements n and a key k, and here it is returning 0. Now we are going to define our function search L in search L, which is taking an array, number of elements n and a key k. Now comparing for I equals to 0, I less than n, I plus plus, and here we are comparing each element. If a of I is equals to k, then return I. Otherwise, if it is come out of the loop, it going to return -1. And here we are printing it using +1, because if it returns -1, then we are going to print is 0. It means that element is not present there. Now let us run our function. Here is some error. I was not declared in the scope. Okay, here we forgot to declare I. Let's declare I. Now let's again run our code. Let's put custom input here, standard inputs. Let the size of the array be 5, array elements be 4, 5, 1, 2, 3, and entering 4 to be searched. Let's see. Element found it at 1. Now it is correct that element is present at first position, as we can see here. Now this approach is going to take our time, that is order of n, as we are comparing each element. Time complexity here is order of n. Now we have to optimize our solution. So for that, firstly we will comment all our present code and start from a new beginning. Now in the second approach, as we all know about a binary search, in which we compare mid element to the sides, mid element to the key, and if it is smaller than mid element, we can check on the left array, and if it is greater, then we check on the right array. Now, but in this, firstly we will going to find our pivot. Pivot is the smallest element in the array, so that we can go through the number of shifts it has performed. Basically, in this approach, approach 2, we are going to find pivot. Let's take an example. Example array, that is a is equals to 4, 5, 1, 2, 3, and here our pivot will be 2. That is 1, a 2, I mean by 2 by its index. Pivot index is equals to 2, which is the smallest element. And now we will check if the element we want to find, element to be searched, is greater than a of 0, then we are going to perform binary search in the left subarray if element to be searched is greater than a of 0. Yeah, that's correct, in the left subarray, otherwise in right subarray. Let's write its code too. Just copy these basic int main code from here. All v and also the basic libraries. Now we will name our function as search ub, which basically means updated binary search. int search updated binary search. Here we are taking our array A, number of elements as n, and key k. Firstly, we are going to find our pivot point in p is equals to find pivot, in which we are going to passing our a array number, array name, and the number of elements. And here we are going to define our function find pivot. Basically, it is a function which is going to return our smallest element index. Performed. Now let name our index, that is int p is equals to a of 0, and initialize our I for I equals to 0, and here we are checking it from I equals to 1, as we have taken p as our smallest element. Now I less than n and I plus plus. If here we are taking p equals to 0, not p equals to a of 0, as we require the index, not an element. If a of p is greater than a of I, then p is equals to I. At last, we are going to return our index, that is return p. Now, if we have not rotated our array, that is if p is equals to 0, then we are going to simply perform our binary search b, in which we are going to pass our array comma basically array, not an initialized array, int array a, our lower key, that is 0 here for here, and n minus 1, the last element index, and the key k. And if a of 0 is less than p, then we are going to search in it here, search b, and we are going to check it from in the right sub-array. A is 0 and up to p minus 1, up to p basically, because it is less than or equals to, and comma k. No, here it is will not be equals. And here, if none of it is true, the thing is true, then we will going to check it in our right sub array, that is from a to a is the array, p is the lowest index, and the last index, that is n minus 1, and our key k. And now we are going to define our function. Firstly, we require to return it, just returning it from here to, and return it from here to. Now we are going to define our function, that is binary search function, int search b, and which is going out taking our array, lowest element l, lowest element index, in which our element is present, int h, highest index, basically it's a range from l index to h index, and our key k. This is our main function, finding the key in a given array. Now let's perform our function. Firstly, we are going to find the middle element, as we are comparing our middle element to the key, and otherwise performing recursively our function. h by 2, and now if a of mid is equals to k, then return mid. Otherwise, else if a of mid is less than k, it means our array. Let's take an example for it, so to understand it better. Suppose our array is again here 4 5 1 2 3, and we have to search 2. Suppose we have to search 3, and we have a range of 1 to 3, and middle element is 2. Then we are going to check in the right subarray as 3 is greater than 2. So in the right subarray, so we are going to return it in again searching a binary, search B, in which we are going to again present A, and our mid plus 1 and minus h basically, and k, and else return search B, A, comma up from L to min minus 1, and it's k. If L is less than h, then only, less than or equals to h, then only. Else return minus 1. Let's see if it is correct or not. Here we are let's just check our code, what we have exactly did, and this is the basic thing. Here we find out the our power rate. Here we have check it from k, not p. K is our key, and it is in this. Now we are going checking in our left subarray, and if the element is present in left subarray, is going to binary search it here, otherwise here. And let's perform our code with the custom inputs. Let's run our code. It's greater than or equals to 0 आएगा यहाँ, greater than or equals to k. Now let's again check. Element found at 1. Let us just pass some element which is not present here, that is 0. Now let us check if it is, what will be its output. Element found at 0. Now let us check it for 2. Run code, and it gives us the correct output. Now let's analyze its time complexity. As we are comparing again and again the middle element, its time complexity for here we are performing log n searches, but in this part we are performing n comparisons to find our pivot. So basically the time complexity of our entire function will be order of n plus log n, that means order of n. So we need to here I will write firstly number of comparisons to search an element is log n. It means search function has time complexity order of n. Now we can update it in some little way, that we will not find a pivot, we will just compare the middle element. Now, firstly I will just comment out the whole code so that we can understand our next part of code with better understanding. Next approach, this. Now in approach 3, but how we will going to do, we will first perform a check the middle element with the key. If it is equal, we are going to return it. Otherwise we will check if our leftmost element meant, that is our lower element, is greater than or less than middle element. Now if it is greater than the middle element, it means that left subarray is not sorted and right subarray is sorted. And if it is less than the middle element, that means our left array is sorted and right array is not sorted. Like, take an example here again, a equals to 4 5 1 2 3. Here our middle element is 1 and 4 is greater than 1. It means our right subarray, that is 4 5 1, is not sorted, but our right subarray, that is 1 2 3, is sorted. So we will check if our element is present in the sorted array or not. If it is not present, we are going to recursively solve it in this, and otherwise we are going to perform in the same subarray. And same thing goes with the right subarray. If it is sorted, we will check on it if the element is present in it, otherwise we are going to check on other. Now let's write its code, just taking the simple code from here only, just copy pasting it, and a little more code, that is files and our binary search code. We will just going to change here in it. Firstly we will update it here, search in the B, and we are going to send it here 0 and minus 1. 0 is the lowest element index and minus 1 is the highest element index. Not in terms of their value, it's their index value. And now if L is less than equals to H, then check for the middle element. If it is equals, then it's okay. Otherwise let's check whether our right subarray is sorted or not. If a of 0 is 0, L rather than 0, we are entering here L. If a of L is less than a of mid minus 1, it means our left subarray. And let us check if an element is present there or not. If a of L is less than equals to k and a of mid minus 1 is greater than or equals to k, then we will searching in it, search B, and pass all these things like a, L, mid minus 1 and our key. Else it must be present in the right subarray. Now we are just simply pass it in a right subarray. Search B, A, comma mid plus 1, comma H, comma K. Here if it is it means if the left array is not sorted, then automatically our right subarray is sorted. Now just directly checking if that element is present here or not. if a of h must a or simply write a of mid plus 1 is less than equals to k, and a of h must be greater than or equals to k, then just search b a comma l comma a comma mid plus 1 comma h comma k. Otherwise, if the element is not present in the right subarray, it must be present in the unsorted left subarray. Search a comma l comma mid minus 1 comma k, and here we are returning these values, that is return from here, and similarly we are returning it from here to here two and here too. Now let's run our code and see what we have exactly did. Let us check it for an element which does not exist. Firstly, an element founded as 0. Let us check for all the elements present in the array. 4, it is showing it to be present at 1, and which is correct. Let us check it for 9, an element founded at 0, and let us check it for 2, and it is present at 4th position, and it is correct. Now let us analyze its complexity, and here we are just making the log of and compares, as we are only checking its middle element. So time complexity of the code, of our code or complete program is order of n. So that's all about our program, and that is searching of an element in an sorted and rotated array.